Okay, so we have done equations with absolute value before, and we saw that there were two answers we had to find in that case, because it was possible that it was equal to the positive version or the negative version of the answer. Now here we'll do something very similar, but it's with inequalities. So when solving inequalities that involve absolute value, there are two cases to consider for inequalities involving less than or less than or equal to. So we talked about compound inequalities before. So ones with absolute value are the and version of compound inequalities, either and, not, or. So let's look at their example. Let's say we were told to solve the absolute value of 3a plus 4 is less than 10. So the first thing we do is very similar to what we did with the equations, which is just write it just as it is, but without the inequality. So you see how 3a plus 4 is less than 10. We just take away the absolute value and write 3a plus 4 is less than 10. So you can see they solved it. I think you guys are good at this now. We subtract 4 from both sides, get 3a is less than 6. Divide both sides by 3 to get rid of the 3. Sorry about that. And so we get a is less than 2. Now we'll deal with the graph later. But let's go ahead and talk about the other scenario. So one scenario is that we just rewrite the inequality just as it is, but without the absolute value signs. The other scenario is we write 3a plus 4 just the same way, but we switch both the sign of the answer, just like we did with the equations, and the direction of the inequality sign. So if you look at these two compared to each other, no difference in the left side. It's 3a plus 4. But here we flip both the inequality sign and we flip the sign of the answer. So we go from less than positive 10 to greater than negative 10. And solving that's not difficult. We just subtract 4, get 3a is greater than negative 14. Divide both sides by 3. And you get negative 4 and 2/3, or you can say negative 4.6 repeating. And I won't be picky about exactly where you place this, as long as you put them in between the correct two whole numbers. In other words, negative 4.6 is between negative 5 and negative 4. So I'm not going to measure to make sure you put that in exactly the right spot. I'm just going to make sure you're between negative 5 and negative 4. So we have a is less than 2. So we put an open circle at 2 and shade this way. And then we say a is greater than negative 4.6. So we'll put an open circle somewhere between negative 5 and negative 4 and shade that way. Now you can do them individually, like we talked about before with compound inequalities. And you see where they overlap, where they intersect, is between negative 4.6 and 2. And since these have no or equal to's, that's why they're both open circles. Now, as it turns out with these absolute values, anytime the beginning is a less than statement, it's an and statement, which as you look at the problems below on your paper, you can see that's what most of them are. But if it's a greater than statement, it's an or statement. So if you have a less than to begin with, it's an and. Less than, I'm making bad puns, I'm sorry. Less than or greater is an or statement. Okay, so we'll solve each inequality, then graph the solution set. So first, we'll just rewrite it just as it is, but without any without any absolute value. So we get y is less than 3, so we put an open circle at 3 and shade to the left. We also do y is less than negative 3. So we have to flip the inequality sign and change the sign of the answer to a negative. So this will also be an open circle. It'll be a -3. And I said it, but I forgot to change it. This is greater than. I'm sorry. Because you have to flip the inequality sign and flip the sign of the answer. So we'll go bigger in that case. So we'll have an open circle at -3 and +3 and shade in between. Got a little more work to do on number 2. I'll have to do some evaluating. So first we write it just as it is, but without the absolute value signs. We add 4 to both sides, and we get x is less than 8. So I have an open circle at 8 and shade it to the left. Then we write it, but we flip it to a greater than sign and make it a -4. We add 4 to both sides. We get x is greater than 0. So that'd be an open circle at 0. We shade it to the right. So this covers the whole line we're given, 0 to 8, and we shade in between. So we have solved this with these two and with these two, and we graphed them here. So we'll keep rolling. So this is going to be an or situation because this starts with a greater than instead of a less than. So it's important to pay attention because since this is a greater than we're starting with, you'll have a greater than in all of them because we flipped the inequality sign. But the ones that start with greater is the ones that we have to consider to be or. So we have y plus 4 is greater than 2. Subtract 4 from both sides. Get y is greater than -2. So we put an open circle at -2, shade to the right. We also do y plus 4 is less than -2. So we subtract 4 from both sides. Get y is less than -6. So remember with or, it's fine if they don't overlap. Because this one's going to start at -6 and go to the left. So this one has no overlap, but that's fine. Or it doesn't have to overlap. Anywhere either one of them is true, we'll use it. Okay, number 4, we're back to the and formation because we start with less than. So we do b plus 2 is less than or equal to 3. We subtract 2 from both sides. We get b is less than or equal to 1. So I have a closed circle because the equals to at 1, and I shade to the left because it's less than. Then I write the second scenario where I change it to greater than or equal to and make it a -3. I subtract 2 from both sides. I get b is greater than or equal to -5. So I put a closed circle at -5, shade to the right, so you can see where they overlap, is from -5 to 1. So just like they have closed circles at -5 and at 1, we will too, and we'll shade in between. Let's flip to the back. So number 5 is a less than, so it's an and. So we'll begin by doing w minus 2 is less than -4. Add 2 to both sides. We get w is less than -2. So open circle at -2, shade to the left. Now our second scenario, we keep w minus 2, but we change it to greater than, and we flip the sign and make it a +4. So we add 2 to both sides. We get w is greater than 6. So we put an open circle at 6 and shade to the right because it's greater than. Now remember, less than means it's an and statement. So our answer occurs only where these two overlap. And these two never overlap. So we would have to say no solution for this one. on an and statement, which is all the less thans with absolute value, we have to look at where they overlap or they intersect, and these never intersect, so there's no solution. Okay, 6. It's a greater than, so this is an or statement. We'll do t plus 2 is greater than 4. Subtract 2. We get t is greater than 2. So open circle at 2, shade to the right. Then we set up the second scenario where we change it to less than, and we change the sign to negative 4. So I'll subtract 2 from both sides. Get t is less than negative 6. So I put an open circle, a negative 6, and I do it to the left because it's less than. So I think this is very important to make sure you remember the difference. Now we talked about this in the previous section with compounds. This is an and statement. And only works where they overlap or intersect. That's why this one is no solution, because these two lines never overlap or intersect. Or statements are the union, meaning no matter what they are, we bring the two together. They don't have to overlap. So even though these may look similar, this one is an and, that makes it no solution. This one is an or, meaning we just draw these two lines the way they are, and that's our answer. Because with and, both have to be true at the same time over some interval, and that never happens here. With or, it can be just one of them, or both, to be true to work. And since this one's true here, we include it. Since this one's true here, we include it. Okay, number 7. The rest of them are ands, in fact, 7, 8, and 9. These are all ands. So we do 2x less than or equal to 8. Divide by 2. We get x is less than or equal to 4. So we put a closed dot at 4. Shade it to the left. Then I rewrite 2x, change it to greater than or equal to, and make it negative 8. Divide by 2, and I get x is greater than or equal to negative 4. So closed dot at negative 4, shaded to the right. So this one covers the entire line they gave us. And we shade everything in between. And we use closed dots because it's an or equals to on both sides. So it's closed dots for both negative 4 and positive 4. Okay, this is also an and question. So we write the first one just as it is, 5y minus 2 less than or equal to 7. We add 2 to both sides. 5y is less than or equal to 9. Divide by 5. And if you type that in your calculator, you get 1.8. So again, I am not going to measure and be picky about you being exactly at 1.8, but you must draw the point between the number 1 and 2. So even if you're right here, which is more like 1.5, I'm not going to be picky about that. So you put a closed circle at about 1.8 and shade to the left. Now the second scenario, we flip the inequality sign to greater than or equal to, make it a negative 7. So we add 2 to both sides. We have 5y is greater than or equal to negative 5, and divide both sides by 5. Get y is greater than or equal to negative 1. So we put a closed circle at negative 1. It's greater, so we go to the right. So where these overlap, because this is an and statement, is from negative 1 to positive 1.8, and we shade in between. Last one. This is also an and statement because it's less than. So we put p minus 0.2 is less than 0.5. And notice, they're all tenths on the number lines. This won't be too hard to graph. We add 0.2 to both sides. We get p is less than 0.7. So we put an open circle at 0.7 because there's no or equals to. We shade to the left. Now our second scenario, we keep it as p minus 0.2. make it a greater than, and make it negative 0.5. So we change both the sign of the inequality, or the direction of the inequality, and the sign of the answer. We add 0.2 to both sides. I get p is greater than negative 0.3. So I put an open circle at negative 0.3, shade to the right, so you can tell the overlap from negative 0.3 to positive 0.7, and I shade it in between.